So the assignment for section P2 and P3, that's due tonight by 9 p.m. P4, Wednesday. And then here's the next assignment, section P5, numbers 70 and 78. That's going to be due Thursday, 5/20, right? Oops. Yeah. Again by 9 p.m. And then the second WebAssign, we'll make that due Monday. So that's going to be 5/24 by 9 p.m. All right, so we need enough practice on all of the sections that we cover, enough drill, so to speak, so that we can get the right understanding and effective understanding of the material. Let's go over a few problems in P4. So we did one example at the end of class last time, so let's do a few more things. Let's see, what was assigned was 59 to 85 odd. There. 59 to 85 odd, and then 94. And the one I assigned to turn in were 68 and 60. So with number 59, well, let's go over. So section P4. With number 59, there's two parts to each one of these. We have part A, x to the 3/4 times x to the 5/4, right? Simplify the expression, meaning combine all of the like factors, so that would be the x's here. And remember that when you have the same base of different exponents, you just add the exponents. Just the only difference here between this and the previous section is that we're doing rational exponents. So that's just x squared. Part B, y to the 2/3 times y to the 4/3. All right, so you just add the exponents again. It's going to be y to the 6/3, which is y squared, right? 59, 61. Let's do 61. So 61a, w to the 4/3.
Wait, sir, I have a question.
Sure.
So on B, it says y 3/3 and y 4/3?
Y to the 2/3.
Oh, 2/3. Okay, sorry, I couldn't read that. My bad.
Sorry.
Thank you.
Over w to the 1/3. Right, so we have three exponential expressions with w, but they're all multiplied. So again, you just add the exponents. So this becomes w to the 6/3 multiplying these two over w to the 1/3. And then when you're dividing two exponential expressions with the same base, what do you do with the exponents? what do I do with the exponents here?
Subtract them.
Right. W to the 6/3 minus 1/3, so W to the 5/3. I don't know why they insist on keep using the same base in all of these, but that's what they're doing. Not same base, I'm sorry, same denominator, but that's what they're doing. So a to the 5/4 times 2a to the 3/4, that whole thing to the third. And then a to the 1/4. All right, first, let's take this exponent 3 and distribute it through here. All right, remember exponentiation distributes over multiplication. So this becomes 2 to the third times a to the 3/4 to the third over a to the 1/4. Right? We have two expressions multiplied here, 2 to the third, a to the 3/4 to the third. All right, so this becomes a to the 5/4. 2 to the third is 8. Now, because that's a number and doesn't involve the unknown quantity a, it's customary to put the number first. It's clearer that way. A to the 5/4, and then we multiply the exponents here, right? So that becomes a to the 9/4 over a to the 1/4. So altogether we have 8a to the 14/4, adding the exponents here. So then we have 8. Okay, so now, like with this expression, now whenever you have w to the 6/3 over w to the 1/3, right, w to the a over w to the b, it's equal to w to the a minus b. But again, we don't normally think of it that way. Sometimes we do, okay, but not always. Here, right, we often think of canceling one factor from the top to one factor on the bottom. So here, we'll subtract the 1/4 from the 14/4, and we leave 13/4. All right, we cancel the a's on the bottom with the a's on the top. So then we're left with 8a to the 13/4. And since we've emptied out all the the factors on the bottom, it's just a 1, not a 0, but a 1, right? Because it's essentially a to the 0 on the bottom. But then, of course, you don't want to write something like that over 1. So that would be the simplest form. Any questions on those? I hope you guys are doing the assignments, as much as you can. I don't know what your goals are educationally. I'm assuming since you're in college algebra that, you're on a track where you want to try to do calculus, or a statistics type track or something like that. But studying these other subjects requires, you can't do it without, being able to do the algebra. Unfortunately, the algebra is the basis of all these things. So it's not doable without the algebra. So, if you're still, a little slow, and the algebra needs to be something that you can do quickly without thinking too much about it. Right, so it's a matter of practice, guys. Matter of practice. Let's see. 63. Well, we did stuff like that already. 65. Let's let's give 65 a go. Looks like a good one. Eight y to the third to the minus 2/3, like that. Okay, distribute the exponent over, well, when they say simplify here, they mean don't use negative exponents. Sometimes negative exponents are appropriate, but if you want to get rid of that negative exponent, right, you can just go like that. Take the reciprocal of this thing, which is 1 over 8y to the positive 2/3 power. Exponentiation distributes over multiplication. So now, what is 8 to the 2/3? What is 8 to the 2/3? What is the meaning of that rational exponent? 8 to the 2/3. It means the third root of 8 squared.
Would it be 8y to the third in parentheses to the 2/3
Oh, yes.
on the bottom?
Sorry, yeah. I lost my third there. You're right. Okay, what is the meaning, specific meaning of 8 to the 2/3? So the denominator is 3, so it's the third root of 8, that whole jazz there, squared. Or it's 8 squared, third root. What's the third root of 8? What number cubed is 8?
2.
2.
Right, so that's 2 squared, so it's 4. So this is 1 over, and then multiply these exponents. 3 times 2/3 is just 2, right? So that's 4y squared. B. U to the fourth, v to the sixth, to the minus 1/3. So let's make that a positive exponent by rewriting like this. Distribute the exponent over the multiplication. So this becomes 1 over u to the 4/3, v to the 6/3, which is 2. By the way, pay attention for a second to the way I'm writing things. Now let me tell you about something that maybe you haven't heard yet. Maybe you have. But I stress this because, like, I've been teaching math at a university level for like 30 years. So there's one thing I've noticed over the years, and that's the following. Is that the way mathematics is written affects understanding. And understanding is reflected in writing things correctly. I'm not sure which comes first, but the two go together. The way you write things and understanding about the different ways of writing things are important. What am I doing here in all these problems we're doing so far? Okay, I'm writing this expression, and then I'm saying that this expression is equal to this expression. And then this expression is equal to this expression. And then this expression is equal to that expression. And I think that's the best one. That's the simplest one, so I kind of circle it as the final answer. And when I say equal, I use this symbol. I don't use this symbol. I don't use this symbol. I don't use any other symbol. Equal is given by this. Not this, this. Is this an equation, what I'm writing here? Is this an equation, what I'm writing here? The answer is no. It isn't an equation. Is this an equation? This thing right here? This is not an equation. This is an expression. Nor is this an equation. What is an equation? An equation is, something with a left-hand side and something with a right-hand side, with an equal sign in between. Okay, and with an equation, you often want to solve an equation. Okay, we haven't done any of that yet. There's not been a single equation in the course thus far. Okay, an equation is something that you solve. It's got a left-hand side and it's got a right-hand side. Okay, this is a string of equalities. I'm evaluating an expression. This is an expression. And I'm an algebraic expression. And I'm evaluating that algebraic expression using a string of equalities. Okay? I'm not solving anything. I'm just evaluating an expression. Later on, we'll solve equations, but we need to learn about expressions first. These distinctions become important as the math gets more complicated. Okay, so developing the right habits now and the right understanding now, saves you that problem later. Without fail, okay, in 30 years of teaching, I have not seen someone who understands the material not write things correctly or understand about the right way of writing things. Okay, nor have I seen people who write things correctly not understand the material. The two just go together. Okay, so let's do something. 67. All right. So 67, we've got part A, x to the minus 2, let me write this a little bigger, x to the minus 2/3 over y to the 1/2, x to the minus 2 over y to the minus 3, all that to the 1/6. Okay, let us take the exponentiation and distribute it over the division. So that becomes x to the minus 2/3 over y to the 1/2. And then x to the minus 2 to the 1/6 over y to the minus 3 to the 1/6. And then in these nested exponential expressions, you multiply these. By the way, the parentheses here are not necessary. They have it written in the problem, but it's good not to write parentheses when they're not needed. And then, of course, you have to write parentheses when they are needed to make the expression defined properly. But if you put them in superfluously like this, it clutters up the expression. All right, so x to the minus 2/3. Remember, when you multiply two fractions, a, b over c, d, if I have two fractions multiplied like this, you just multiply the numerators and multiply the denominators. So that's what I'm going to do right now, all in one step. So minus 2 over 6, x to the minus 1/3, y to the 1/2, y to the negative 1/2, oops, half. Notice I'm simplifying those fractions just, in one step. All right, so now add the x to the minus 2/3, x to the minus 1/3. Well, same base, different exponents. We add those exponents. Same thing down at the bottom here. So I have x to the minus 1 over y to the 0. What's y to the 0? And for any base, a to the 0 is what?
1.
1. Not 0, 1. A times 0 is 0. A to the 0 power is 1. So that's x to the minus 1 over 1, but just take the negative exponent and bring it down here, and so you just get 1 over x. B. So x to the 1/2 y squared all that to the 4th power over 2y to the, the whole fraction. Two y to the 1/4, all that to the 4th power, times the fraction. 4x to the minus 2, y to the minus 4 over y squared, all this to the 1/2. Okay, let's distribute the exponentiation in both of these expressions here over the multiplication and the division. So this becomes x to the 1/2 to the 4th. Let's do it, without writing. Well, I'll do it, that's fine. I mean, if you can skip this step, it's definitely a good thing. But do all the steps you need to do. How many steps do I want to see you do? Since we're on the topic. I mean, I don't know what your, teachers in the past have told you, but how many steps do I want to see you do? So I'm doing more steps than what I think is necessary here. How many steps do I want to see you do?
Like all of them?
As few as possible. I don't want to see a lot of steps. You do the number of steps that makes you comfortable, okay, to understand the material. I mean, if it takes you 10 steps to finish a problem, fine. Okay? Do I want to see 10 steps? No. Okay? But if you need it, you do it. Okay? If you can do it in 2 steps, fine. That's better for me. As few as possible. Okay? Always write as little as possible. I know in the past that people would say, "Wow, show all your steps" or something like that. No, not really. Not really. Your calculations should always be as streamlined as possible. I can tell if, I'm not accusing anybody of anything, but I mean, like, in the past, like, sometimes when students, rarely, very rarely, but once in a while, students do cheat. I mean, I can tell just by looking at it. Not because they didn't have the correct steps in there, it's just there's no way to go from step A to step B without showing something, right? Like, even I wouldn't be able to do it. So, I mean, I know that, something fishy is going on there. So don't worry about that. Just show as few, write down as little as possible. Anyway, so let's do these multiplications now. 1/2 times 4 is 2. 2 times 4 is 8. 2 to the 4th, that's 16. 1/4 times 4 is just 1. Y to the 1, but don't write the 1. 4 to the 1/2, what's that? What's 4 to the 1/2 here? What's that mean? What's 4 to the 1/2 mean?
Square root.
Square root, right? A to the 1/2 is just the square root of A. So 4 to the 1/2, that's square root of 4, so it's 2. X to the negative 2 times 1/2 is negative 1. Y to the minus 4 times 1/2 is y to the minus 2. And then this is just y. Let's multiply the two fractions together. So I have 2x squared, x to the minus 1, y to the 8th, y to the minus 2, over 16, and y times y, we'll just put y squared. All right, add these exponents with the same base. Again, remember it's customary to put the just actual number without the unknown quantity up front. Oh, let's do a cancellation here. So the 2 cancels with the 16, leaving 8, right? So this becomes x to the 2 minus 1 is just x to the 1. X to the 8 minus 2 is x to the 6. Or, sorry, y to the 6. Over 8y squared. So I have y squared on the top, y to the 6. So y squared on the bottom, y to the 6 on the top. Cancel that in here. 6 minus 2 is 4. Right? So the y squared cancels with the y to the 6th. And I have x, y to the 4 over 8. Right, so number 68 kind of, pretty similar to that. Similar to that. These two. Then also up to 85. So these later problems, they use that sort of quote-unquote radical notation, which is not always the standard. So in number 81, let's just do 81. Fourth root. So remember that, these radical notations or root notations, right? They're interpreted in terms of exponents, of rational exponents. So this is x times y to the 1/2, and on the bottom, 16xy to the 1/4. So now it's just the same as what we were just doing. So this becomes x to the 1/2, y to the 1/2, 16 to the 1/4, x to the 1/4, y to the 1/4. 16 to the 1/4, right? That's the fourth root of 16. Right, fourth root of 16 is what? What number to the fourth power is 16?
2.
2.
So that's just a 2. So we have x to the 1/2, y to the 1/2 over 2x. Canceling the x's on the bottom and the y's on the bottom of the top. A half minus a fourth is a fourth. All right, so we're left with x to the 1/4, y to the 1/4 over 2. All right. So those notations are with the radicals in them. They're less standard, except for this. The square root notation is of course used a lot, but this stuff, these they're not really used all that often. Although people do. So just keep in mind that's what they mean. Okay. Alrighty. Let's move on to section P5. So P5 is on algebraic expressions. Right, and also polynomials. It's not the title in the book, but I'll stick that in there. All right. So, given a variable or unknown quantity, x. So by the way, there's a difference between an unknown variable and an unknown quantity and a variable. An unknown quantity is just some quantity you don't know what it is. So you give it a letter, x. A variable is an unknown quantity that changes, that can change. And that distinction becomes important later in calculus. Here, not as much. But anyway, given an unknown quantity, or a variable. So in algebra, they're kind of interchangeable notions. A monomial is of the form, in like this. So should be right. R x to the p, right? Where this is a real number, and that's a real number, usually rational. Usually rational. Okay. So something like 8x to the 5th, right? Or 17x to the 3/4, or 17x to the minus 3/4. Or the number out front doesn't have to be an integer, it doesn't even have to be rational. Square root 2 x to the minus 1, something like that. Right? So just a real number, x exponent. Okay, that's a monomial. An algebraic expression is a sum and difference of monomials. Oh, yeah, some of these can be negative if you want. Minus x to the squared, something like that. An algebraic expression is a sum and difference of monomials. All right, so you got a bunch of monomials together. 12x to the 5th minus 2x to the 4th plus x to the 1/2 minus x to the minus 2, and so on and so forth. I'm sorry, guys. I'll have to excuse myself for just a moment. All right, sorry, guys. So, for example, an algebraic expression, sum and difference of monomials, looks like this. Notice that in operator precedence, right, an algebraic expression is evaluated in what order? What operations are evaluated first? Exponents come first in the following order. 1 exponents are evaluated first. 2 multiplication is evaluated second. And 3 then addition and subtraction. Multiplication and division, I guess, if there is any division. Okay, so that's the order in which these things are evaluated. For example, in this algebraic expression, if we let me get rid of that 5th power and 4th power. So in this algebraic expression, let's make that 3. Make this just x. So evaluate for x equals 4. For x equals 4. So I'm gonna replace x with 4. Minus 2 times 4 plus 4 to the 1/2 minus 4 to the minus 2. Right, so this is equal to, well, first I can evaluate the exponents. 4 to the 3rd, that's 64. 12 is nasty. Why don't we make it, why don't we put a half here? So it's a half times 64 minus, well, that exponent, there's no exponent there. 4 to the 1/2, that's the square root of 4 is 2. 4 to the negative 2, that's 1 over 16. Then we have, first we did the exponents, then we do multiplication, 32 minus 8 plus 2, and then 1/16, or division, if there's any division. Then you do addition and subtraction. So this becomes 34 minus 8, 26 minus 1/16, which is, I don't know, 26 times 16, 416, 415 over 16. All right, so that's the order in which it's evaluated. That's the standard way in which an algebraic expression is written, the standard form. So when the operations are in this form, that is a monomial, or sorry, an algebraic expression is written as a sum of monomials, it is considered to be in standard form. That's the standard form for an algebraic expression. Right. Sometimes people will call it simplified form. It doesn't really make sense. The standard form, I mean, what does simplified really mean? Oh. One more thing. It is written as a sum of monomials with different exponents in each monomial. Then it is considered to be in standard form or simplified form. I don't know. I don't know why the book insists on using simplified all the time, because it doesn't really mean anything consistent. So, okay, fine. So how do we take an algebraic expression that's in some other non-standard form and get it to standard form? Okay, or how do we simplify it if you wanna go with with that kind of vocabulary. Or another term, could often be thought of as expanding or something like that, but we'll talk about that. So how do you add and subtract algebraic expressions? Basically, whenever you have two monomials with the same exponent, you add their coefficients. Right? So if you have ax to the m plus a or b x to the m, like that, this is equal to a plus b x to the m. And then if you had negative there, then you could do that as well. Probably you've seen this stuff already, I imagine. But all right, so in examples of usage, so let's say 6x to the third minus 2x squared plus 10x minus 8 plus 3x to the fifth minus x to the third minus 2x. Okay, so simplify by adding like terms. What does that mean? Monomials with the same exponent. Okay, well, here we go. So I have 6x to the third minus x to the third. So how many x to the thirds does that give me? 6x to the third, x to the third. 5x to the third. Minus 2x squared, and there's no x squared here, so it's just minus 2x squared. 10x minus 2x. So how many x's does that give me?
8.
8. And then I just have a number. That's like considered a monomial in x because it's like x to the 0. Okay, so I still have that 8. And then here I have that 3x to the fifth. Okay, it's standard to put the exponents in decreasing order or in increasing order, but it's sorted somehow. So this would be 3x to the fifth plus 5x to the third minus 2x squared plus 8x minus 8. Okay, and that would be a final answer. Notice I'm still evaluating expressions. I'm working in a chain of equalities, but because these expressions are all kind of long, I got to go top to bottom rather than left to right. But that's fine. Or, if we were to subtract these two things, let's do a different one. 10x squared minus 5x minus 10 minus 2x to the fifth plus x squared plus x plus 1. So now we're subtracting. So I have 10x squared minus 1x squared, give me 9x squared. Minus 5x minus x is minus 6x, right? Minus 5x minus x is minus 6x. Minus 10 minus 1 is minus 9. Minus 2x to the fifth is positive 2x to the fifth. Right? There's no x to the fifths here. No x to the fifths in here. So
Wouldn't it be minus 11?
Sorry? Oh, minus 1, minus 11, yeah, minus 1. Mine is plus 2x to the fifth. All right, did we get all the terms? 5, 2, 1, 0. Again, standard practice to put them in decreasing order or increasing order, whichever you like. And there's our final answer. All right. So adding the algebraic expressions, that's easier. What's harder is multiplying algebraic expressions. Oh, by the way, I forgot to mention, when the exponents in an algebraic expression are all non-negative integers or positive integers, it's called a polynomial instead of a monomial. So let me put that there. So I can put it here. Whoops. So when the exponents in an algebraic expression are all positive integers, the expression is called a polynomial. So there's monomial, and then there's polynomial, and then that's just for integer, positive integer exponents. If you've got some rational number exponents and negative exponents, then you just say algebraic expression. All right. Multiplying algebraic expressions or polynomials. Okay. Whenever you want to do that, okay, you multiply every term in the first expression by every term in the second expression. Oh, by the way, what are terms? What are terms? Factors are things you multiply. Terms are things you do what with? You
Add or
add and subtract. Okay? Terms are things you add and subtract. So when you want to multiply two algebraic expressions, each term in the first expression by every term in the second expression. And then combine the factors, like so, by using a x to the m times b x to the n is equal to ab x to the m plus n. So, for example, if I've got an algebraic expression or a polynomial that looks like this, So there's 3 terms in this algebraic expression. There's 2 terms in this algebraic expression. All right, so 3 terms here and 2 terms here. And what you're going to do is you're going to take each term in this expression and multiply it together with each term in that expression. So the 3x squared gets multiplied by the x and the minus 2. The minus 10x, I'm going to use orange, the minus 10x is going to get multiplied by the x and the minus 2. And the 5, what color should I use here? Red, blue, yellow, is going to get multiplied by the x and by the minus 2. Combine factors using this and then add. And subtract these products and then combine factors using this thing here. So, okay, 3 terms by 2 terms. So I'm going to take every term in the first and multiply it by every term in the second and add all that stuff up. Subtract, add as appropriate. So, for example, here, okay, let's take 3x squared multiplied by x. So 3x squared times x plus 3x squared times minus 2. Next, I'm not going to be able to fit it all in one line here. Try to shrink that a little bit. All right. That should work. All right, so I took the 3x squared and I multiplied by the x and the minus 2. And then I added those guys. And now I'm going to take the minus 10x and multiply it by the x and multiply it by the minus 2. And then I'm going to take the 5, multiply by the x, I'm going to leave out the parentheses there, and then multiply by the 2, negative 2. Okay, just like that. Now let's combine these. So x squared times x is x to what power? X squared,
Third.
x to the
Third.
plus, okay, well there's no x's there, right? There's just the 3 and the negative 2, so those get multiplied together. So that becomes minus 6 x squared. X times x is x squared, so this is minus 10 x squared. This is plus 20x. This is 5x minus 10. Okay, and now combine the like terms, the monomials with the same exponent. So I've got this monomial here, maroon, with exponents 2, and these monomials here with exponents 1. So those get combined together. So I got 3x to the third minus 16x squared plus 25x minus 10. There's the algebraic expression, or the polynomial here in this case, in standard form, right? The exponents, it's written as a sum of monomials, right? Where exponents are evaluated first, then multiplication, division, then addition, subtraction. Okay, let's look at another example. You need some drill to start getting used to this kind of thing. Here's another example. Oh, 1052. Okay, so 6x minus 5. So multiply these monomials. Or polynomials. 6x minus 5, 2x plus 1. So I'm going to multiply the 6x by the 2x. 6x by the 1. And minus 5 times 2x. And minus 5 times 1. Alright, so this becomes 12x squared plus 6x minus 10x minus 5. 12x squared minus 4x minus 5. Combining this term and this term. So when the polynomials of the algebraic expressions have two terms each, then there's this mnemonic people often use, FOIL. I kind of don't like the mnemonic so much. If you like it, that's fine. First, outside, inside, last. I mean, why first, outside, inside, last? Just take every term here and multiply it by every term here. So when you don't have two terms and two terms, then the FOIL doesn't make sense. Just every term here by every term there, and you're good to go. Another example. If you've got just one term in the first monomial, let's say minus x minus 2x to the 1/2 times x squared minus x plus 1 or something like that, then you just have to take this term and multiply it by all of those. So it becomes minus 2x to the 1/2 times x squared plus 2x, x to the 1/2, minus 2x to the 1/2. So adding these exponents, x to the 5/2 plus 2x to the 3/2 minus 2x to the 1/2. All right. So it's 10:55. That's pretty much everything in this section. So let's get started on those homework practice problems. Do as many as you can this evening. We'll cover the discussion, these practice problems tomorrow. 15 to 75 every sixth problem. So give those a go. We'll look at them tomorrow, and then yeah, go ahead.
So do you have the updated like due dates on your website? Is that correct information?
The ones that I announced.
Because it said that the handwritten in P2, P3 was due tonight.
Yeah, right there. Due Monday.
Okay, thank you.
Mm-hmm. So every day, I update the website, course website with announcements. All right, so this was from last Friday, and of course, sometimes I'm going to change the due dates because things don't go as fast as I would like. All right, so this will all be posted, the notes today after class, okay? Have a nice afternoon, everybody. I'll see you tomorrow.